Welcome, I'm Tim Sever. Today we're going to look at the slope of the tangent line, or the derivative of a well-known function. So let's take f of x equal x squared, and let's find the slope of the tangent line to f, to the graph of f, at, let's say, x equal 1. And let's look at a picture before we venture too far forward into the problem. So let's look at the parabola. Not a very good graph there. Okay. So this is f of x equal x squared. So let's say here this is 1. 1 squared is 1. So this is 1. And so here is the point on the graph 1, 1. And so the tangent line looks like that, something like that. Of course, if this was a computer rendering, it would be a lot better. So here's the tangent line, and we want the slope. Clearly from the graph it's positive, but we don't know if it's 1 or 2 or 3, but we want the slope of the tangent line to the graph at this point. And this is the point 1, f of 1, which is, as we know, in this case is 1, 1. Okay, so let's see how the problem goes. Now eventually we'll have a theorem. We will know by theorem, by the time you're watching this video, you probably know the derivative of x squared is 2x, but we want to do it by the definition, just as an illustration. An illustration of technique. So we know that f prime of x is equal to, by definition, the limit as h goes to 0 of f of x plus h minus f of x over h. Again, it's the limit as h goes to 0 of the so-called secant lines. In other geometric or graphical terms, the slopes of the secant line approach the slope of the tangent line if there is a tangent line to the graph at the particular x value. All right, so we have the limit as h goes to 0, f of x plus h, in this case is just x plus h quantity squared, minus f of x over h. And the way I'm deciding to tackle it, I'm going to just plug in 1 at the end. So really what I'm doing in this part of the problem, rather than computing the slope at 1 directly, I'm going to show that f prime of x is equal to 2x, and then I'll plug in the 1 to get the slope of 2. So I'm doing it in a slightly more general fashion than I may have otherwise done. Okay, so here we can cancel or subtract out the x squareds. And now we see there's an h in every term remaining. I'm going to factor that out to prepare for the cancellation on the next step. Or actually 2 steps, the subsequent step. And we'll again use our famous theorem of functions that agree at all but one point for limits, which means we can cancel in the limit, we can cancel those terms. Clearly you couldn't cancel these if these were functions, but okay. And so now we're ready to evaluate this limit. There's nothing to prohibit us at this time for plugging in 0 for h, so we get 2x. All right. So as was intended, what have we shown? So we now know that the derivative of f is 2x. So if f of x is x squared, the derivative of x squared is 2x. Now, this is a bigger problem, much bigger problem. What I really wanted to know what's going on here at 1. So we could say at x equal 1, at the x value of 1, or other language we could say at 1, 1, point on the graph, m is equal to f prime of 1, which is equal to 2 times 1, which is 2. Okay, so we have m equal 2. So the slope of the line is 2. Reiterating or stating the final conclusion, therefore, f prime of 1 is 2, and this is precisely what we were asked to find, slope of the tangent line. To f at that value. All right, very good. Thank you.